Solving systems of equations. What is a system of equations? A system of equations is simply a collection, a set of one or more equations with the same set of unknowns, i.e. variables. And these equations can be linear or nonlinear, and more often than not, these equations have multiple variables. For now, we're going to consider a system of two linear equations and two unknowns. So what exactly does it mean to solve a system of equations? This means just finding a unique ordered pair that satisfies both equations simultaneously. So on a graph, it just means finding that point where the two equations intersect each other. And depending on the types of equations that you're given, you're going to have basically three different things that can happen, three different possible outcomes. If the system of equations is what's called consistent, then you're going to be able to determine a unique solution. This occurs when the two equations cross each other at some point. However, if the system of equations is inconsistent, it means that there's no solution whatsoever. So this occurs when the curves, when graphed, are parallel to each other, so they never cross each other. And then finally, you may have something that's called a dependent system, which means that even though the equations may look slightly different, they actually are the same thing, and they lie on top of each other, which means that there's an infinite number of solutions. We'll go through examples of each. And there are different ways that you can solve systems of equations. The first one is just through a graph. You can graph both equations and see if they cross and where they cross. You can use algebra. The first way is the elimination method, and that one's in the text. The one that I like to use is the substitution method, and that's what we'll go through today in this lecture. So let's go through an example. Suppose you're given this system of two equations with two unknowns, 2x plus y equals 10 and y equals 3x. So two equations, and the two unknowns are x and y. Let's try to find a solution to this system if one exists by using graphs. So I'm given these two equations, and I'm asked to graph them and to show on the graph where a solution might exist. So I'm given that y is equal to 3x and also y is equal to 10 minus 2x. So I've got these two equations and two unknowns. The two unknowns are y and x. And so I'm just going to graph these guys. And I'm going to use this positive quadrant because in economics, most of the variables we deal with are positive in nature. So this is our origin. So of course we're going up here. This is increasing positive numbers. We move to the right. This is increasing positive numbers as well. So the first one I'm going to graph is this y equals 3x. And let's use a different color. Let's use blue for this. So I know that there's no intercept, right? So if this was a plus b, this was a plus b, that b would equal 0. So I know that this guy's going to go through the origin. I also know that it's upward sloping. I know it's upward sloping because the slope is positive. So let me just mark this off. Remember, we only need 2 points to create a line. But here's my first point, the 0, 0. And the slope tells me that when I increase x by 1, the y goes up by 3 units. So 1, 2, 3. That's going to happen a lot. I don't know how to get rid of that. Sorry, so this is a point on here. And then if I increase x again, from 1 to 2, y is going to increase even further, but only by another 3 units. So here's 6. Okay, so here we are. So here's another ordered pair, 2, 6. And I can keep doing this. I'm just going to connect the points here as best as I can with a straight line. And then I'm going to label this as y equals 3x. So here we have our first equation, and every single ordered pair on this line solves this equation. Now we want to show another equation on this graph, y equals 10 minus 2x. So what I like to do when I see a downward sloping curve, and I know it's downward sloping because the slope is negative, I like to find the two intercepts. I like to find the vertical intercept and the horizontal intercept. So I know immediately that the vertical intercept is 10. Right, so here's 7, 8, 9, 10. So I know that that's at least 1 point. I could just say, all right, well, I know that when x increases by 1 unit, y is going to fall by 2. So x increases by 1, y is going to fall from 10 to 8. So this is another point. But I can also just find that horizontal intercept. The horizontal intercept, substitute 0 in for y, that's a comma, and solve for x. Right, so 0 is equal to 10 minus 2x. I can solve for it, add 2x to each side. 2x equals 10, and then I can divide by 2 on each side, and I get x equals 5. So I got this other ordered pair. Let's see, 3, 4, 5 right here. And I can connect these points. So let's try to do this as best as I can as well. Ooh, that was really terrible. Okay. Still bad. Okay. All right, so it looks something like this. Supposed to be a straight line. Supposed to be a straight line. So that's pretty good. That's pretty good. So this is y is equal to 10 minus 2x. Let's create a barrier here. Okay, so every single point on this line is a solution to this equation. But the question asks us, what's the solution to both of these equations? And that occurs where these guys cross each other. Let's make this red, and let's just mark this off. So at this point here, it looks like, based on this very terribly drawn graph, that a solution 2, 6 satisfies both of these equations simultaneously. So we can say, I'm going to call it x star y star to represent a solution is going to be 2, 6 based on my graph. When you're using the substitution method, there's a series of steps that you can follow, and sometimes you won't even have to do the first or second step because it's already done for you. But let's go through them before we go through an actual example. First, you're going to choose one of the equations and solve for a specified variable. For example, solve for y. Then you're going to substitute the expression that you created in step 1 into the other equation. And what you should come up with is an equation with only one variable in it, x. Using that equation from 2, you solve for that new specified variable and put a star above it to denote that it's a solution, for example, x star. Then you're going to substitute the value you found in step 3, for example, x star, into one of the other original equations. And you'll once again come up with an equation of one variable. And you solve for this specified variable and put a star above it to denote its solution, for example, y star. Now what I like to do is check my proposed solution by substituting in that x star into both equations just to make sure that the y star that comes out is the same. So now let's use the substitution method to solve that same system of equations that we solved using a graph. So again, I'm given this y equals 3x and y equals 10 minus 2x. So let's look through these steps. Choose an equation and solve for a specified variable. So it looks like this is sort of already done for us. We already have y, which is going to be our specified variable, over on the left-hand side. Now substitute the expression found in step 1 into the other equation. This will result in an equation of one variable. So let me show you what this means. So I've got y is 3x, and I have y is equal to 10 minus 2x. So substituting in just means that I'm going to take this guy. I'm just going to take this guy, if y equals 3x, and if y equals 10 minus 2x, I can just go like this. I can say 3x is equal to 10 minus 2x. So look at this. So now I have an equation where there's one variable. And I know that when that's the case, I can solve a number out of this. So let's do some algebra. We're going to solve for x. I'm going to add 2x on each side. We're going to get 5x equals 10. Then I'm going to divide by 5. And I get, let me put it up here, I get that x star, I'm going to call it a star to denote that it's a solution to this system, is equal to 2. And like that corresponds to our graph, so that's pretty good. And then I'm going to, that's only half the problem, right? Now what I need to do is I need to back substitute this value, x star equals 2, into one of the equations, into one of them, and see what y star is. Now just to double check myself, I'm actually going to substitute x star into both equations and make sure that I come out with the same y. So let's say y star is equal to 3 times 2 is equal to 6. I could have just put this x star into the other equation and I should come up with the same thing. 10 minus 2 times 2 is equal to 6. So that's it. So using math, I've come up with the solution to this system of equations as 2, 6. Quiz yourself. Solve the following system of 2 equations and 2 unknowns. Use the substitution method. Pause the video now and try this on your own. The answer that you should come up with is 2, 1. Solve the following system of 2 equations and 2 unknowns. Use the substitution method. Pause the video now and try this on your own. The answer you should have gotten is 4/3 and 5/3. So far, we've worked with consistent systems of equations. That means that we can find a unique solution in x star, y star, where 2 curves cross, where that ordered pair that we find simultaneously solves both equations. But we said in the beginning of the lecture that sometimes you may get something that doesn't really make sense mathematically. And this is because you can have a system of equations that are parallel to each other. And this means that they're inconsistent. It just means that the curves never cross each other, so there's no solution. And in another instance, you may find that you get an infinite number of solutions, things that are always true. It just means that these equations lie on top of one another. So let's go through an example here. Suppose you're given the following 2 equations and you're asked to solve for them. You're asked to solve this system of 2 equations and 2 unknowns. X minus 2y equals 1 and 2x minus 4y equals -3. So I'm going to solve each equation for y because we're going to end up graphing it. And so you should verify that this is correct, but when I use my rules of algebra manipulation, I'm going to get an equation y is equal to 1/2 x minus 1/2 for the first equation, and for the second equation I'm going to get y is equal to 1/2 x plus 3/4. Okay, so I'm going to use a substitution method. So if we're solving a system of simultaneous equations, we know that if this is true, then I can just plug whatever I have in here into there. So I get 1/2 x minus 1/2 is equal to 1/2 x plus 3/4. So I'm going to do some algebra here to try to solve for x star, right? But look what happens. I'm going to subtract 1/2 x from each side. And I'm left with a -1/2 equals 3/4. So what exactly is going on here? You set everything up correctly. You did the correct math. What's going on? Let's show what's going on with a graph. So I'm just going to do these coordinates here. This is x and this is y. We're going to graph it out because we know that when we're solving for a system of equations, we're trying to find where the 2 curves intersect. So let's first graph let's graph y equals 1/2 x minus 1/2. So I know that this vertical intercept is going to be -1/2, so I'm just going to put that down here. So I know at least one point on my graph. I also know that the slope's 1/2, so that means that when I move over by 1 unit on x, I move up by 1/2. So it looks like, oh, that froze, sorry about that. So it looks like I'm going to be at this point as well. And remember, you only need 2 points to create a line, so I'm going to connect these with as straight a line as I can. Maybe going down this way will work better, kind of. So this is supposed to be a straight line. I'm going to go ahead and label this y is equal to 1/2 x minus 1/2. And let's graph this other one. Let's see what's going on. So y is equal to 1/2 x plus 3/4. I'm going to see that the vertical intercept is 3/4. So let's maybe, I don't know, about here. This is fine. Actually, you know what? Let me move this down a little bit. Okay, so this is 3/4, and I know that the slope is 1/2. So when I move over x 1 unit, y is going to increase by 1/2. So that's going to be 5/4. So I've got my 2 points here, and now I can connect these. And so what should happen, and of course, trying to draw as straight as possible. This is y is equal to 1/2 x plus 3/4. What happens is that we've got these two parallel lines. They're never going to cross. So you're going to get something. You're going to get a solution that sort of looks like this, where at first it doesn't make sense. It doesn't necessarily mean you did your math wrong. It means that these curves actually never cross. So one thing to keep in mind, if instead of graphing everything, you can look at a set of equations and say, well, if the slope's exactly the same and the intercepts are different, these equations are parallel and there's not going to be a solution. Alright, so now suppose you're given a set of equations that looks like this. 5x equals 10y plus 5/2 and 2x minus 4y equals 1. So what I'm going to do, I'm going to solve each variable, I'm going to solve each equation for the variable y. So let's just go through this. So 5x equals 10y plus 5/2. So I'm going to get y by itself. So I'm going to subtract 5/2 from each side. 5x minus 5/2 equals 10y. So now I divide each side by 10. And I get 1/2 x minus 1/4 equals y. So here's my first equation. I've solved it for y in case I want to graph it later on. Okay, so now let's solve this guy for y. So I've got 2x minus 4y equals 1. I'm going to add 4y to each side and also subtract 1 from each side. So I get 2x minus 1 is equal to 4y, and then to get y by itself I'm going to divide by 4. And I get 1/2 x minus 1/4 is equal to y. Oh, this should not be here. Okay, so it looks like I have the same two exact equations. I have the same exact equations. So if I wanted to graph these out, it's going to look like this. They're both going to have an intercept of -1/4, and they're both going to have a slope of 1/2, of a positive half. So they're both going to lie on top of each other. Okay? So when this happens, this is called dependent system. Oh, sorry, infinite number of solutions, which is something that we don't really care about. We want that unique solution. So let me just show you very quickly the math. So what you come up with is, of course, when you set them equal to each other, you're going to get something that is always true. So when I solve this out, I'm going to get 0 equals 0, which is always true, which indicates that it is a dependent system and there are an infinite number of solutions. Solve the following system of two equations and two unknowns. Use the substitution method. Pause the video and try this. The answer you should get is, well, actually no answer. There's no solution to this. The two curves are parallel. And finally, solve this system of two equations and two unknowns. Use the substitution method. Pause the video now. And you should find there's actually an infinite number of solutions. If you were to rearrange for y for each equation, you'll find that they're actually the same exact thing. So they actually lie on top of each other.